Alright, students, for today's exercise, we're going to start in a series of interpenetration and developments. So this is basically we're going to have two solids that penetrate, and they are going to have a line of penetration somewhere, and then we're going to basically unroll them to see what they will look like as flat sheets. Okay, so looking at this one first, the grade 12 diagram here, you can see that you have the main pipe here, what we also call the primary. Okay, and then you have the branch going in on the side. If we look there in the top view, which we also sometimes refer to as the secondary. So the first key here to this entire drawing is that both pipes are round. Okay, the center of the main pipe is parallel with the vertical plane. Okay, and the base is parallel with the horizontal plane. And the two penetrate at a 90-degree or perpendicular angle. Okay. And then the distance from the center to the top, of course, is 17 plus 18. Okay, so if you want to locate that center there. And then the distance from the silhouette of the main pipe to the end of that pipe is actually 20 millimeters. So that's 20. Okay. Then I'm going to use this video to explain both the grade 11 and 12. So the grade 12 page is page 7.1 and the grade 11 page is page 7.2. Okay, so if I compare this one to the grade 11 page, then you'll actually see that the only real difference between the two, besides the fact that the measurements are slightly different, is that in the grade 11 page, okay, which you've done last year, the branch was actually the same diameter as the main, okay? And that seems like a small difference, but it makes the drawing a lot easier to do if they have the same diameter. Okay, so I'm going to explain today's drawing with the grade 12 page. Okay, but at the end, I'm also going to be looking at the grade 11 result, just to clarify. And if you can do the grade 12 page, you certainly can do the grade 11 one as well. Then just to recap, the front view, of course, is sitting here, and the top view is sitting there. So obviously, this is in first angle orthographic. And if we look at the grade 11 page, the same thing. The top view is below the front view, and the front view is sitting here. So this is also in first angle orthographic projection. Both are on scale 1:1. So no change to the measurements on your page. Now going to the answer sheet, you can see that you have to redraw the front and the top view and separate them on the XY line. You can see my front view is resting on the XY and the top view has a 1 centimeter gap between them. Again, you can change that gap to whatever you want. You can have a gap on both sides as well. Okay. Then very similar to the grade 11s, except for the grade 11s, the branch will have the same diameter. Now, obviously, this is more grade 10 level to redraw front and top views, so I'm not going to explain how to draw this. Then the first thing that you want to do is you want to realize that in both cases, both the top of the main and the branch has round bases. Therefore, we have to divide them into 12. So I'm going to draw a little auxiliary like this, just a half circle. You can do a full circle if you have the space. And you're going to divide into 6 if it's half and 12 if it's a full circle, the construction. But please take into account that you have to use your 30-60 degree set square. So this line will be at 30 degrees and that one will be at 60 and the same for that side. Okay. Then the next thing that you want to do is you want to find the line of penetration. Now this is going to be very similar for both the grade 11s and 12s. Okay. So before you can do the developments, you have to complete the front and top view. Now the top view is already done. There's the line of penetration that runs in the top view. It's actually on that circle. Okay. But in the front view, obviously it will be some type of a curve. But understand it's not difficult to do. So you just take your circular base points, so 1, 2, 3. Obviously the one in the middle counts as well. So the center already acts as 1 point. So this is a penetration point. So all you do is project the construction line until you hit the line of penetration, and then you take it up to the front view, and then you just repeat by taking the same lines from the same construction circle, which represents the base, and you take them across and you'll get this little grid here. Okay, now for example, you can use numbering to help you, but what's in the top and in the middle here, okay, because this is on the top and below. Okay, so the bottom point is actually below that one, and this will be on the side. So this point will in fact be here. Well, the point that you see here at the top of the top view, that point, if we go up, will actually be here in the top view and there as well. So it repeats at the bottom because it's symmetrical. And then you just go, let's say you start here, you go down and right and down and right and down and right, and then you go down and left and down and left and down and left, and you'll plot all your points. Again, if you have a very steady free hand, you can do this very light, and then you can make it solid afterwards, and then you can connect the curve, and it will look something like this. So there's your line of penetration in the front view. So now your both views are complete. So we want to do the development of the main pipe. So for that, we're going to need the diameter or the radius. So here they give us the diameter is 48. Now we know that the circumference of the circle is 2 pi radius, but it can also simply be pi times diameter. So pi times 48 will give us what we need. So if we go back to the drawing, we say, right, so pi times diameter, if I use my calculator, that will give me the diameter is 48, and we simply multiply that by pi, and that will give us 150.79, or if we will, can maybe round it off to 151. So the distance there from A all the way through, that's about 151, and the height we get from the front view. So if we go to the diagram, you can see here that it has a diameter of 36. Okay, so 2 pi radius, or simply diameter times pi, will give us the length that we're going to need for our secondary development. So if we take the 36 with our calculator, so we simply say 36 multiplied by pi, and that will give us a length of 113 rounded off. Okay, so that line has a length of 113. Now in both cases you have to divide the development into 12 equal parts. Now the reason for that is because in the top view we divide our cylinders, both of them, into 12. So that's why we have this half circle here for the branch, and this is also why we divide the main into 12 segments. The center also acting as segment lines. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of them. Now, some students will go and take that length, which is 151, divide it by 12 on the calculator, and they'll simply mark that down. Okay. Now you can do that, but in the exam you get 2 marks for this construction, and you have another one here for the branch. So if you don't do the divisional construction, then you're not going to get the 4 marks there for the 2. Okay. So if you want the marks, you're going to have to do that. Okay. Now, if you're stuck in the exam with time and you want to skip that, fine. Okay, but understand it's not for nothing. So we're simply going to go to our main one, and we're going to draw the lines down for now, just construction lines, and we take it down, and that will divide into 12 equal parts in each case. So I'm going to do the branch first. So step 1, you're going to take each point and just draw a construction line up. You don't know how high, just draw it high enough. And then you'll see that I've actually marked down these horizontal lines going across the profile. Okay, so where do I get that from? Well, if you go to the top view, all the lengths here are true lengths. So for example, obviously I'm only doing 1/2 because it's symmetrical. So for example, here's the first line. There's the first true length that I need, or fold line on the cylinder. Okay, in inverted commas, fold line. The next height will be here. The third one will be there, and the fourth one will be there. So those are the 4 true lengths you're going to need. So all I do is I take this distance from the base to the point, from the base to the point, from the base to the point, from the base to the point. I take those heights and I mark them down here as well. So from the base to the line, from the base to the line, and I draw the lines across, and that will give me that little grid. Of course, you also could have taken it from your top view. You could have taken the same distances there. There you can actually see the grid. Okay, so the same distances that I have here in my front view, I just marked down on the development, okay, just stretched out instead of circular. And then all you have to do is you start here, that's the lowest end, and you go up and right for the second point, up and right, and when you hit the top, you go down again, right? So it's down and right, down and right, down and right, and then you go up and right again. Just keep repeating, plotting the points until you have all of them, and then when you connect the points in the outline, you're going to get the branch, and it's going to look like this. Okay, so there you can see the curves going round. Now, why must you start on the shortest end? Okay, you can technically start there as well, but the shortest end, if this was cut out of metal, let's say, okay, and you've got to weld, if you start at the long end, for example, you can have a slightly bit more welding. Now, imagine making 10,000 units like this in a factory, and you're the floor manager, Okay, and that extra bit of welding can cost a lot of money if you're dealing with 10,000 units. Okay, so you want to minimize the amount of welding that would waste time and money. So we normally start on the shortest end, and that's what it will look like. So to finish off with a branch, we just have to add the fold lines. Now remember that these are technically imaginary fold lines because we're dealing with a cylinder. Okay, and this is the answer for the branch. Not very difficult to do. Okay, almost identical with the grade 11 page of 7.2 as well. Right now for the grade 12s, if we go to your main development of or A, okay, so we're going to take the same penetration points, the 7 of them. It's actually 12. Remember, 5 are behind them. Okay, so we're going to take these same 7 points and we're going to take it across. And these are going to be the horizontal lines that we're going to need to plot our points. Now, normally, guys, what you would do is you would go in the exam and say, okay, I'm going to number. So obviously not going to start cut it open here. We can cut it on the far side because you want the hole to be in the middle. Okay. So I'm going to cut it here 1. You can go clockwise or anti-clockwise. I went anti-clockwise round, so 3, 4, 5. So right up to 5, we're not actually going to have a penetration point. We're only going to have 2 penetration points between 5 and 6. Okay. Because remember the same penetration points we use for the branch, we have to use for the main as well. So we're going to have 2 points between 5 and 6. Okay. And then 1 between 6 and 7. So we're not actually going to use 5 and 6 as penetration points, only 7, because remember the center also acted as a line of penetration. So 5 and 6 will not be penetration points, but only the points in between, and that is the main difference between the grade 11 and 12 one. Okay, with the grade 11 drawing, you're going to be using 4, 5, 6, and 7 directly as your points of penetration, but because this cylinder here is smaller than the main, your penetration points will actually not line up with 4, 5, 6, and 7. The only one that will line up is 7 itself. So 7 will act as a penetration point, but 5 and 6 will not. Okay. So what you're going to do is, in the exam, you can actually go and measure the distance, let's say from 5 with your ruler. Now, obviously, this is a curve, so technically that's not correct. Okay. But if you measure the distance from 5 to 6, or let's call this 5A and that 5B. So from 5A to 5B, you can measure that distance with the ruler. And then from B to C, you can measure the distance with the ruler. And then from C, you can measure the distance. If this is 6, you can measure the distance to 6B there and then to 7. And you can take those measurements and plot them on your development. Okay. Now, I'm going to show you something today, how to do it accurately, but we will actually see that it makes very, very, very little difference. Okay, so while technically not correct, you can do that in the exam. So what I want you to do is, if I go back to the development, okay, of the primary, you can see that I actually numbered it. So I divided into 12 like before, and I started at 1. So I numbered it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, back to 1. Remember, we cut it open at 1, so it will go back to that. So here you can see that from 6, I measured the distance, the first one. So you'll see these red broken lines. So from 5, I measured the 1 and 2. And then from 7, I measured the other one. So if we go back to the top view here, I measured from 7 to that penetration point. So let's call it 6B. And then I measured these two from 5. So I measured one distance from 5 and then another distance from that one. And I plotted them down just like I did from the measured from the top view. And there you can see I marked them down on the base and then I just took the construction lines up. So I'm just trying to differentiate between the two types. Okay, that's why I'm using these red broken lines. Now I'm going to do something higher grade. Okay, that's only applicable for the grade 12s. Okay, to show you how to accurately get these lines without measuring on the top view with a ruler. Now to measure accurately, what you're going to do is, if you go to your development, you would, if you measure that distance, so one segment, okay, represents 30 degrees on the circle, the base. So if you measure that distance, it's actually 12.56 millimeters. Now, obviously, I'm using CAD, so I can get it much more accurate. You might measure it and get 12.5, okay? But that will still be better than just measuring straight with a ruler. So one segment, or 30 degrees, equals 12.56 millimeters. So keep that in mind, okay? So if we go back to the top view, And I've done this little diagram here. Okay. Now, obviously, I'm going to take the angles with a protractor. So from 5, I took the distance or the angle to the first point of penetration. So from 5A there to 5B there has an angle of 11.5 degrees. So what you would do is, you would say, right, 11.5 degrees. I divide it by 30 degrees because each segment is 30 degrees. And that will give me about 0.38, and I multiply that by the 12.56, or the actual distance of each segment. So 12.56, and that will give me a distance of 4.8, which I have then rounded off to 5. Then if we take the next one, what is the distance from 5 to 5C, that angle? I take 19.5 degrees and I divide that by 30 degrees, and that would be 0.65, and I multiply that by the 12.65 millimeters, and that will give me, rounded off, 8 millimeters. And then last but not least, the distance from point number 7, the penetration point, to 7B here, that angle there is 22 degrees. So I take 22 and I divide it by the 30 degrees. I multiply it by the actual distance of each segment, which is 12.56. And that will give me, rounded off, 9. Okay. So if we go to this little diagram, I've drawn it out. Okay. So the distance from 0.5 to 6 has two measurements that you can plot. We've got 5 and 8. Penetration point 7 to the point or segment point 6, which is not actually a point of penetration, and we get 9. Okay, so we've got 5, 8, and 9. Keep that in mind. So we've actually calculated that properly now. 5, 8, and 9. Now let's go see what would be the distance if we actually go and measure that down. Okay. So if you actually go and measure the distance from 5A to 5B, now it's very small, but I can read it. It's 4.77, okay? Which means that it's actually about the same thickness as your clutch pencil lead, okay? So it's very, very little difference. And then if we take the distance from 5A to 5C, we get the distance of 8.12, very close to 8 anyway. And then if we go for this angle here, for 6B, so we take the distance from 7A to 6B there, we get the distance of 9.16. So again, very, very close to 9. So if we go back to this little table here, 5, 8, and 9. Okay, so the difference between just measuring it with your ruler and actually going and calculating it is so minute that it's almost not worth mentioning. Now, if you were drawing this in CAD, yes, then you would use the proper method. But on paper, it makes such a small difference that you can basically just measure on the top view, which is a true shape, and just measure with your ruler and plot the points down. So I've taken it across, I've marked the other lines as you can see down here. So from 7, so from 5 I measured 1, 2, and I measured the same from 9, 1, 2 distances. And then from 7 I measured the same distance both ways, which you take measure from your top view. And then all you have to go and plot the points on them. Again, your test is that you should have 12. If you have more or less, then obviously you made a mistake somewhere. So starting on number 7 here at the top, okay, then it goes down and right. You skip number 6 because 6 is not a penetration point on this one. It will be for the grade 11s, but not for you. And then you go down and left, then you go down, and you skip number 6 again. You go down, you go to the side. There's 7 again at the bottom. It repeats. So obviously it's going to form a hole, and you want to go and connect the points with a French curve. If you do it freehand, please do it very light first and then connect the points once you're happy with the result and make it dark. Right, so just to show you what it will look like when it's done. So your main development, okay, or the primary, obviously there's the distance of 151. You took the height from the front view. There's the hole that's in the middle. Sometimes they do require that you draw half a hole on this side and half on the other. Now the advantage there is it does reduce the amount of welding, but it also makes the structure very, very weak. So normally we put the hole in the middle. Okay, so for the branch, we keep the short ends on the side, while with the main, we normally put any hole that might be in there in the middle. And that's it for the grade 12 page. So if you're the grade 12s, you can actually log out. Now for the grade 11s, you can actually see that the branch development is virtually identical to the grade 12 one. It's a little bit deeper there, okay? But it's got basically the same shape. It's got a sharper corner there because obviously it's been affected. The main difference here will be with the main development, or what we call the primary, okay? The main pipe. So because your branch was the same size as your main, when you use the same method as before, so you take your lines across, you bounce it off the line of penetration, which is exactly half that circle, you take it up, you take the same points from this auxiliary view here, you take it across, and when you have this little grid, again, you start on those points there where the two meet, where the two pipes meet, and then you go down and down and right and down and right and down and left and down and left. You just follow the grid. Now, it just so happens that when you look at the front view, so you're looking at the line of penetration, it forms exactly a straight line. That is very, very rare. It can happen, but it's not common, okay? For that to happen, the two pipes has to be exactly the same size. And remember that it only appears to be a straight line. It is in fact a curve, but from the front it looks like a straight line. Okay, so when you plot your points across, the same as before, the difference is that let's say you've got point 1, 2, 3, 4. Right? So this is point 4, 5, 6, 7, 8, 9, 10. So you're going to have penetration points from 4 all the way around to 10 when you divide this main pipe in the top into 12 with your set square. And the same 12 points, you're not going to have points in between that you have to worry about like the grade 12 drawing. So you take those 7 points across, you take it up, you mark them 1, 2, 3, 4, 5, 6, same 7 points, take it across, okay? So you don't have to go and mark extra lines in between like with the grade 12 drawing, okay? Your fold lines exactly line up where you need them. So you're going to, let's say, number 1, 2, 3. Remember your penetration point was 4, 5, 6, 7, 8, 9, and 10. So 4 to 10. So you go 1, 2, 3, 4, first line of penetration. 5 also, 6, 7, 8, 9, and 10. You take the lines up. Then you take these lines across. So you can use your fold lines straight away to go and plot your points. And it so happens that yours will look like this funny little elliptical shape. It looks almost like an eye. But other than that, it's the same. You still need the line of division to get the 12 parts for your length. Okay. And obviously you're going to have slightly different sizes, so your lengths will vary. It will not be the same as grade 12. So you've got to follow your diagram and just go pi times diameter to get the length of each one. Okay. All right, so you'll see that in fact your main and your pipe is the same length. And that's it, guys. So if you follow those steps, you should be able away.